Hey everyone, in this video we'll learn more about quadratic functions. So as you can see right here, we have this function f of x equals x minus 1 squared minus 4, and we have it drawn right here. And this is just our standard parabola that has been transformed. It has been shifted once to the right, as you can see with this minus 1, and it has been shifted down by 4, as you can see with this minus 4 on the outside. So this is really just x squared shifted to the right by 1, and it's been shifted down by 4. So that's what's drawn in orange over here. So let's talk about this parabola that we have in orange. And let's take a look at the lowest point, the minimum of this parabola. This point, 1 comma negative 4. So 1 comma negative 4. So this point, in any parabola, either the lowest or the highest point is called the vertex. So this point is called the vertex, and it is at 1 comma negative 4. It is at that point. So this is called the vertex, and by the way, it doesn't always have to be the minimum. If it were also the maximum, then the maximum would also be the vertex. So just as a quick example, we have f of x equals x minus 1 squared minus 4. Let's say we had negative f of x. So negative f of x, we could just graph that real quick, negative f of x. I'll go ahead and graph it in red. So it is negative f of x just reflects the entire parabola over the x-axis. So it would look something like this. So instead of 1 comma negative 4, we'd have 1 comma 4. And then instead of negative 1 comma 0, that would state negative 1 comma 0. Same thing as 3 comma 0. And then negative 2 comma 5 would be negative 2 comma negative 5. 4 comma 5 would be 4 comma negative 5. And this is the parabola, but it has been reflected over the x-axis. This is negative f of x in red, and it has been flipped upside down. So it doesn't have a minimum, but it has a maximum right here. This point 1 comma 4. So 1 comma 4, this is still a vertex. So in any quadratic function, in any parabola, the vertex is simply either the lowest or highest point. In other words, where the parabola starts is one way to think about it. So let's go ahead and erase this other parabola we drew, just the flip parabola. Let's erase that as well. And let's also talk about the axis of symmetry. So I'm going to draw a line right here, all the way down the middle. This green line, this is a vertical line. This is the vertical line x equals 1. And this line, x equals 1, is known as this parabola's axis of symmetry. So axis of symmetry. And what makes this line so special is that it cuts the parabola down the middle. It splits the parabola in half. As you can see, the parabola is now symmetrical about this line. It is symmetrical on this side as well as on this side. And it cuts the parabola down the middle. And every axis of symmetry will also pass the parabola's vertex, which is down here. So notice the vertex, the x-coordinate of the vertex is 1. And our axis of symmetry is x equals 1. So that makes sense. The vertex's x-coordinate will always be the same x-coordinate as the axis of symmetry. So this vertex right here happens to be at 1 comma negative 4. And that is the axis of symmetry in green. Now let's talk about one more thing. We actually have these points already in red, negative 1 comma 0 and 3 comma 0. So these are important. So right over here is, I'll just write them here, negative 1 comma 0. And we also have 3 comma 0. Those are the two red points right here. And these have special names. These these we know as the x-intercepts. So these are the x-intercepts because these are the x values of this function when y equals 0. So these are the x-intercepts, but in the case of a quadratic function, these can also be called zeros. So these are the zeros of the function, or they can also be called roots. So these are the roots of the quadratic function. So when you're asked, find the roots of this quadratic function, f of x, then you know that the roots are these 2 points, -1, 0 and 3, 0. These are the roots, the zeros, and the x-intercepts at these points. So now let's talk a bit more about the function itself, f of x. So f of x, as we could see right here, it's written in this form, x minus 1 squared minus 4. But let's go ahead and actually just expand it. So we can tell that x minus 1 squared, this is a binomial squared. And if you go ahead and actually expand that, that will come out to x squared minus 2x plus 1. And then we have this plus 4 remaining, or this minus 4 remaining right here. So I'll just write that minus 4 here. And then you can combine these like terms, plus 1 minus 4. So in the end, you have x squared minus 2x minus 3. f of x equals x squared minus 2x minus 3. So this and this, both of these are the same, they mean the same thing. They are the same exact function. They are just 2 different ways to draw the same parabola, x minus 1 squared minus 4, and then when you expand it, it becomes x squared minus 2x minus 3. So these have 2 different names. This first one up here, this is called the standard form. So this is the standard form, and we'll talk about that a bit more in detail, but that's the standard form. And then this one right here, this is called the general form. So let's talk more about the standard form. So the standard form for a parabola for any quadratic function, it goes like this. F of x equals a times x minus h squared plus k. So that's the standard form, and we'll explain what all these letters mean. And let's also just write down the general form. And I'll write the general form over here. General form. So the general form for a quadratic function, it would be f of x equals ax squared plus bx plus c. So we're already familiar with the general form for a quadratic function, ax squared plus bx plus c. That is a quadratic function because it has a degree of 2, and it follows this form, this general form. But let's get back to the standard form over here. So what is a, what is h, and what is k? What are these? So a, well, let's actually reference our standard form function up here. Our function in standard form is f of x equals x minus 1 squared minus 4. So let's write this function, or let's write our function in standard form. So f of x equals, what is a in this case? Well, if we go back up, there is no a. There is no coefficient right here. So whenever there's no coefficient, you always assume 1. So a is 1. So 1 times, and then we have x minus h. So what is h in this case? H is 1. So this is x minus 1, x minus 1, and then plus k. So what is k in this case? K is right here is -4. So plus -4, plus -4 just comes out to -4. -4. Excellent. So what do each of these letters mean? Well, h and k tell you something very interesting about this quadratic equation. So the vertex of f(x) occurs at the point h comma k. So when a quadratic function is in standard form, we could tell right away what the vertex of this quadratic function is. We could tell right away because h and k, so let me underline these, h and k are right here. What is h and what is k? Well, h is 1. So our vertex is 1 comma, and then k is -4. So our k is -4. So this is our vertex, 1 comma -4. And that makes sense when you look at the graph. When you take a look back at our graph, our vertex was indeed 1 comma -4. So that's why the standard form of a quadratic function is helpful, because you could tell right away by looking at h and k, so by looking at h and k, where the vertex of this parabola is. Great, so that's h and k, but what about a? What does a tell you about this parabola? Well, we know our a is 1, so what a tells you, if a is a if a is a positive number, then the parabola will point upwards. As you can see, our parabola is pointing up, sort of like a U or a smiley face. Our parabola points up. If a was a negative number, so if a was a negative number, if this was -1, for example, so if it were a -1, our parabola would point down. Similar to when we graphed at negative f of x earlier, it would look, if I just graphed that negative f of x again, it would look something like this. So -2 comma 5, -2 comma -5, 4 comma -5. Let's do this. So this red parabola is negative f of x. So we put a negative sign in front of it, and that flips the parabola upside down. So let me go ahead and just get rid of that. Perfect. So that's what a tells you. A tells you whether it will point upwards or downwards, depending on whether it's positive or negative. So that's the standard form of a parabola. And now let's talk about the general form of the parabola. So the general form, f of x equals ax squared plus bx plus c. And we found the general form of this parabola right here. F of x equals x squared minus 2x minus 3. And if we go ahead and just examine what a, b, and c are, by rewriting it down here, f of x equals ax squared. So we know our a, there is no coefficient, so it's just 1. So 1 times x squared plus b, so our b is -2, so plus -2, so we could just write -2, so minus 2x plus c. What is our plus c? -3. So we could just go ahead and write -3. -3. And there we go. That is the parabola, or that is the quadratic function in general form. So that's important to know. And then one more thing about the axis of symmetry. So as we could see right here, our axis of symmetry was at the line x equals 1. It's this green line right here that splits the parabola down the middle. So it's at x equals 1. And if you look at the general form of a parabola, which we have right here, you could tell what the axis of symmetry will be. The axis of symmetry will be at negative b over 2a. X equals negative b over 2a. So x equals negative b over 2a. Let's go ahead and find it. So x equals negative. What's b? Our b is -2. So x equals negative 2 over 2 times, and what's a? Our a is 1. So 2 times 1. And let's go ahead and evaluate this. What's negative 2 in the numerator? That's just positive 2 over. And then what's 2 times 1 in the denominator? That's just 2. 2 over 2. 2 divided by 2 equals 1. And there we go. X equals 1. That is our axis of symmetry. So this right here, x equals 1, is our axis of symmetry. That is our axis of symmetry, and that makes sense. When we go back up to the graph, the line x equals 1 is indeed our axis of symmetry. So that's how you find it algebraically, by looking at the general form of a parabola. You find x equals negative b over 2a, and that will give you the line for the axis of symmetry. So I hope this video helps, and if you have any questions, please leave them down in the comments below, and thank you for watching.